Session 8.4 Testing a claim about a standard deviation or variance. These sessions, we will learn how to do the hypothesis testing for standard deviation or the variance. First, look at the requirement. Sample is a simple random sample. And also the original population has a normal distribution. Okay, look at the notation. N is a sample size, S is sample standard deviation, S squared, this is sample variance. And we have the sigma, that's a population standard deviation. Sigma squared, that's a population variance. And then we have the formula for the test statistic. Okay, so this is the formula for the test statistic. You can see there's a chi-square, means we're going to use the chi-square distribution. And then the degree of freedom, that will be n minus 1. Okay, this is the procedure to test a claim about standard deviation or variance. Okay, we can deal with the standard deviation or variance. So right now here, I only put like standard deviation. First, one of the not hypothesis, standard deviation equal to a value. And the alternate hypothesis, it can be strictly less than, strictly greater than, or not equal to. Okay, when it's strictly less than, it's going to be left tail. Greater than, it's going to be right tail. And not equal to, that will be two tail. Okay, second step, find the test statistic. Okay, N is a sample size that will be given. And this is a sample variance is also given. For the population variance, you could look at the not hypothesis. Whatever this value here, you could plug in this formula. Okay, after we find the test statistic. Step 3, find the degree of freedom and also using your calculator to find the p-value. Okay, for the next line, I will teach you guys how to use your calculator to find the p-value. After you get the p-value, you're going to interpret the result. When your p-value is less than or equal to the alpha, you're going to reject the not hypothesis. When the p-value is strictly greater than the alpha, that will be fail to reject the not hypothesis. And then, step 4, that will be conclusion. Remember on the notes session 8.1, we do have the table, and then we have number 1, 2, 3, 4 conclusion. Okay, so this is the step how you guys use the TI-84 plus or TI-83 plus to find the p-value. Go to second distribution, you're gonna choose the chi-square CDF, okay, it's cumulative. And then what you're gonna put, lower value, upper value, and also the degree of freedom. For example, when you're working on the left tail test, okay, chi-square distribution, we don't have the negative. So the lower value has to be start from 0, okay, from the 0 to the test statistic and then the degree of freedom. For the white tail, okay, test statistic to the 1E99 and then degree of freedom. But when you're working on the two tail, you have to do both of them, okay. You're gonna try on just like the left tail from 0, test statistic and degree of freedom. And you also find it just like the white tail, test statistic to 1E99 and then degree of freedom. After you get these two numbers, you're gonna pick the smaller one, okay? The smaller one, that would be your p-value. Okay, let's try an example. A sample of 25 one-year-old girls had a mean weight of 24.1 pounds with a standard deviation of 4.3 pounds. Assume that the population of weight is normally distributed. And the claims that standard deviation of the weight of one-year-old girls is less than 5 pounds. Do the data provide convincing evidence that the pedestrian claims true? Use the significance level 0.05. Okay, first, step 1, find the not and alternate hypothesis. Remember when you guys working on the not and alternate hypothesis, you only need to look at the claim statement, okay? So this is my claim statement. The standard deviation of the weight of one-year-old girl is less than 5 pounds. Okay, first, we know that we are working on standard deviation. Okay, so the knot hypothesis is standard deviation equal to 5 pounds. And then the alternate hypothesis, here says less than, right? So alternate hypothesis is going to be less than 5 pounds. Okay, step 2, find the test statistic. I'm gonna plug into this formula. Okay, what is my n here? What is my sample size? You say a sample of 25. So you know n is equal to 25. And then what is the s? What is the s in here? It's a standard deviation of 4.3 pounds. Okay, so you know s is equal to 4.3. And how about the population variance or standard deviation in here? You could use the knot hypothesis. Here, population standard deviation is equal to 5. So you could plug in here like 5 squared. Okay, use your calculator. You guys should get 70.75. Okay, now I'm gonna find and interpret the p-value. My alternate hypothesis is gonna be less than. So less than, we will use the left tail. Okay, left tail. Okay, let's take a look here. Left tail. So it's gonna be chi-square CDF from 0 to your test statistic and the degree of freedom. Okay, degree of freedom is n minus 1, which is 24. And then I have a chi-square CDF start from 0 to the test statistic, which is 70.75, and then degree of freedom. Okay, let me show you guys how to use your calculator. Okay, I'm gonna go to second, VAS, and then I'm gonna go down. You could see chi-square CDF. Enter. This is a left tail, so I start from the 0, this is my lower value, to the test statistic, which is 17.75. And then the degree of freedom is n minus 1, which is 24. Okay, enter. You guys should get 0.1850. Okay, so this is gonna be my p-value. Okay, this is my p-value. And then now we're gonna interpret the p-value. We're gonna compare with your p, using the p-value, compare with your significance level. Okay, and then p-value, this is greater than the significance level, 0.05. So that will be fail to reject the knot hypothesis. Okay, last part, final conclusion. Okay, which conclusion we're gonna use? Number 1, number 2, number 3, and number 4. First, we have strictly less than, right? This is an inequality. So for sure, I'm gonna use either number 1 or number 2 conclusion. And then we have failed to reject. So we're gonna use number 2 conclusion. So that is not sufficient evidence to support the claim that the standard deviation of the weight of 1-year-old girl is less than 5 pounds. Okay, example 2. A simple random sample of 30 filtered 100 mm cigarettes is obtained from a normally distributed population, and the tar content of each cigarette is measured. The sample has a standard deviation of 0.18 mg. Use a 0.05 significance level to test the claim that the tar content of 100 mm cigarettes has a variation different from 0.0625 mg, which is the variation of unfiltered king-size cigarettes. Okay, first, why not the knot and alternate hypothesis? Again, look at the claim statement. This is going to be the claim statement. The tar content of filtered 100 mm cigarette has a variation different from a 0.0625 mg. Okay, so here we are working on variation, okay, variation. So this means like the variance, okay, variance. So I have the null hypothesis, variance equal to this number. And then alternate hypothesis that will be not equal to. Because this camp statement, they never mention about less than or greater than. So they only select different form. So this is going to be not equal. Okay, find the test statistic. Okay, n, that will be your sample size. What is n equal to? Simple random sample of 30, right? So n is equal to 30. And then what is the s here? Okay, here they say sample has a standard deviation of 0.18. Okay, so standard deviation is going to be 0.18. So 0.18 squared here. And how about the sigma here? The population variance. Remember, we're going to look at the not hypothesis. Not hypothesis. The variance is equal to 0.0625. So you could plug in here. Okay, use your calculator. You're going to get this. Okay, C. We're going to find and interpret the p-value. We have the significance level 0.05. And then the alternate hypothesis is not equal to. So that will be the 2-tail. And then the degree of freedom is going to be n minus 1, which is 29. Okay, now we're going to use your calculator to find the p-value. Since this is a 2-tail, we have to do for both of them. First, the left tail. Okay, left tail is going to be stuff. The lower value is going to be 0 to the test statistic and then the degree of freedom. Okay, you guys should get 0.0153. And then you're going to find the right tail also. Okay, so it's a chi-square CDF from the test statistic to the 1E99. And then degree of freedom is 29. So you guys should get 0.985. Okay, we're going to pick the smaller one. Okay, so the p-value, that will be equal to 0.0153. And then we're going to interpret the result. Since this number, the p-value, is strictly less than 0.05 here. So we're going to reject the not hypothesis. Okay, D, what is the final conclusion? Okay, which conclusion we're going to use? We're going to use number 1, number 2, number 3, or number 4 conclusion. First, alternate hypothesis, that's a not equal to, and which is 2-tail. So we will use the number 3 or number 4 conclusion. And second, that is a reject, okay? Reject the not hypothesis. So we're going to use number 3 conclusion. So that's sufficient evidence to warrant rejection of the camp that, and then you're going to write down the camp statement. Okay, that's it for session 8.4.